Alrighty, so you have in front of you a little packet, and this is one of these Minnesota-specific lessons. And so have this in front of you and have your pencil ready, because we've got to talk through now using some of our properties and how you can use those properties to simplify expressions that are algebraic, okay? You did some evaluating with some algebraic expressions the other day, and now we're going to do some comparing and ordering of some equivalent expressions. So on the top up here, they've given you a list of 6 different algebraic expressions that look pretty similar. And so what we want to do is test these and see if they really are equivalent to each other, meaning they would produce the same value and they're kind of identical even though they might not look that way. So what they want you to do in step A here is substitute 4 in for the variable n in each one of these and then evaluate it. That's one way to test right away. If we get the same answer, then yes, maybe they might be the same. So let's start in each of these boxes and substitute a 4. 6 times 4 minus 1. Oh, well, plow your way through this one. There's the first one. The second one, here's this expression, and I'm going to substitute a 4 in there. Remember, your order of operations tell you have to do your multiplying and dividing before you add or subtract. So here I get 24. 6 times 1 gave me 6. They did that for you already. 18. Ooh, maybe. Let's see what happens on this one. Substitute 4. You have to multiply before you subtract. You get 24 minus 1, that's 23. This guy is an oddball. Let's keep evaluating some of the rest of these. Substitute 4. Now I have negative 6, but I have to multiply first. Okay, so that gives me 24. A negative 6 plus 24 is indeed 18 again. Substitute a 4 in here. Now inside my parentheses, I have 3 times 4 minus 3. That gives you 12, and 12 minus 3 is 9, which is 18. Last one to test. Substitute a 4. All right, 2 times 4 minus 1 in the parentheses is 7. Here I get 21. All right, so in just evaluating each of these 6, and I'm substituting in a value of 4, it looks to me like which ones appear to be equivalent? Well, these ones that ended up giving me the same value when I evaluated them at the value n equals 4. So the first one, next door, I get n times 6 minus 6 times 1. Not that guy. This is negative 6 plus 6n. And this one, 3n minus 3, the quantity, times 2. And not that guy. All right, turn the page over. Let's see what comes next. You can show that these expressions from the Explore activity are equivalent because they are both equivalent to this. Describe how you can do this. Now we've got to take a step back to when we talked about properties the other day, and I had you make that whole big flip chart. I'm going to start with this expression, 6 times the quantity n minus 1. That distributive property says if you have something being multiplied against an entire blob of information in parentheses, you can multiply each term times whatever's on the outside. So this means 6 times the n, and then I'm going to subtract 6 times the 1. And if I keep simplifying this, I get 6n minus 6. Now, I showed you what this was, and it's asking you to describe, okay? So use the distributive property to simplify. Okay, so this is what I end up with, and I wanted to get 6n minus 6, and I got that. distributive property. Look at the other expression, which started out this, -6 plus 6n. There is a great little property called commutative, which says you can change the order of anything that's an addition problem or multiplication problem, and your ending value will be the same. So what I'm going to do is I'm going to switch the order because this is addition, okay? If I flip-flop the order, the 6n would come first, and then the -6, okay? And 6n plus -6 is the same thing as saying 6n minus 6, and that is using the commutative property. I simply switch the order. Ta-da. Okay, let's see. So I suppose I should put this in the same sort of method or make it a full sentence. Using the commutative property, rewrite the expression. Now, I also happen to use the idea that adding a negative number is the same as subtraction. So that's kind of using the definition of what subtraction means, adding the opposite. I'm just kind of doing it in the reverse order. Now you've shown that you've basically shown that each of these two, which started out looking differently, are the same as 6n minus 6. All right, let's look at number 2. Mike says that by the associative property, hold on, remember what that looked like? The associative property is where you change what you're grouping together with parentheses, okay? So he's saying I can regroup this n times 6 minus 6 times 1 to give this n times 6 minus 6 times 1. And then what he does is he takes this, simplifies that to 0, and says the whole thing's 0. Why is that not true? All right, pause the video for a second and see if you can see why that doesn't work. Did you figure it out? It's because our order of operations, and I should say, the order of operations kind of demands or says that you must multiply before you add or subtract. So you must multiply before adding or subtracting. In this case, it's subtracting. I'm going to get rid of all this mess here. Subtracting. Okay. Mike introduced parentheses and changed the order of operations. You can't do that. Okay. In addition, you can only use the associative property. So I'm going to say only use the associative property with addition or multiplication, but not both. And definitely not with subtraction. Okay, so you see what's going on? There's multiplying and subtraction, and you can't just at will put parentheses in, move them all over, and reconfigure your problem that way. It's not allowed. Okay, all right, so if you want your property chart out, some of your problems today on the next page, you'll be employing the use of commutative, associative, distributive properties. I don't know if you'll get any of the inverses or identities, but it's always good to have that chart out. Now, the second chunk that we're talking about today are about like terms. Terms that are alike have the same variable with them, and if there's an exponent, they have to have the same power. Okay? The number that's in front of your variable, we call it the coefficient or the constant because it's a plain old number. The variable can change, but for example, the 2 doesn't change. So take a look at comparing these columns here. 2x, 3x, just x, psst, there's a number in front of that thing. It's really a 1. I like to make sure I draw that in there so I'm not forgetting that that's really a 1x. They all have the same variable. Each one of these is an x to the first power. They're like terms. Look at these three. X, Y, Z, different letters, not like terms. 1, 5, 100, 7. They're all numbers, plain old numbers. You could add them together. Okay? 1x, 5 doesn't have an x. The 100, that has a letter Y. These are not like terms. You have to have the same exact variable. 3y, 19y, 1y. Put a 1 there. Those all have the same variable to the same power. Look over here. 7a, 5b. Plain old 7 with no variable. Those are all different. We can't combine them. If I came over in here and I said 7a plus 5b, you can't make that 12 something. They have to have the same letter. If I had said something like 7a plus 5a, oh, that works. You have 12a then. That's fine. You can't combine if you don't have the same exact variables. This last one here that I'm putting a star by, we have to be very careful. They all have n's, and they all have n's to the second power. 5n to the second power, 1n to the second power, 12n to the second power. Those are like terms. We could add all those together. 5n squared, 1n squared, 12n squared, 6, 18n squared. Yes, that works. Over here, I have all n's, but they're different powers. This is n to the second power. This is an n to the first power. You can't add those together. You can't subtract them. Okay? 12n to the third power. It doesn't work. We cannot add or subtract these guys and try to combine them into one term. Does not work. All right? So, how do you do this and how do you do the combining of these like terms? Really what you're doing is kind of undoing the distributive property, okay? So take a look at 3x and 2x. They both share the same term x. If you kind of factor that out or pull that on the outside, x times 3 is still 3x, x times 2 is still 2x. We're adding them. Combine the two number values together to give you 5. Now, normally when we write this, we usually put the constant or just the plain number part is also called the coefficient. We put that number in front, okay? 3x plus 2x can be combined into one term, 5x. Same thing here, 7x and 4x. If you just think, hey, my coefficient of this term is 7, the coefficient of this term is 4. I'm subtracting both of these guys. That's the coefficient in front of x. You get 3x. Okay? You're kind of undoing it with the distributive property. You do a subtraction step, and then by commutative property, they're flip-flopping the order. Me personally, I would simply, instead of writing x times 7 minus 4, I would probably write 7 minus 4, put that in parentheses, times x in the back, because you can still think of distributing from the right-hand side. You don't always have to distribute from the left. Okay? We're simplifying expressions by combining together what goes together, but your job with your eyeballs is only combining the terms that are alike. Okay? Let's look at a few more here on the next page. You have 4x, a minus 1x, put a 1 there, plus 2x. If I stopped right here, I think intuitively you would get this. Behind the scenes, you're really using the distributive property. You're thinking, I have a 4, I have a minus 1, and I have a plus 2. Okay, all of those coefficients are what's going on in front of your variable x. So you're kind of pulling that x out of the way and kind of undoing the distributive property and simplifying those coefficients to be 5. And then you have x times 5 or 5x. Usually we put the constant or the number part, the coefficient in front. All right, communicating, examine parts A, B, C in example 1. Describe how you combine like terms. Okay, you go ahead, think about that one. You fill that one out. Pause the video and take a moment to reflect on that. Alrighty, here we go. To simplify an algebraic expression, you're going to use all these properties, commutative, associative, distributive, simplify them, and kind of condense it into the fewest number of terms that you can. Okay, so take a look at this first one. You have negative 7c plus 4d squared plus 11c minus 2d squared. These two both have c's. They should go together in the front. Okay, this is a d squared, this is a d squared. They should go together, and go ahead and throw those in the back. Basically, what we're going to do is rearrange the order. Whoa, 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 that's a subtract sign. Will you simply think of this as plus a negative 2d squared? That way it's all adding, and now the commutative property works. You just flip everything around. Do you notice, though, they don't even write plus negative 2d. They're just thinking, okay, a negative 2d, that's taking away 2d, d squared, subtract 2d. It's all the same. Okay, combine your 2c terms into 4c. Combine your 2d squared terms into a positive 2. Now, you're done at this point because you have different variables. You can't do anything with the 4 and the 2. They're attached to two different kinds of terms, so you just have to leave them both separate. When you take a look at this one, okay, actually I'm going to take a little detour, okay? Jot this one down in the margin. If I have 3 times the quantity, x minus 4, and then I'm going to say plus 2x minus 1, okay? You cannot go ahead and simplify anything until you distribute the 3 across the quantity x minus 4. These guys are like locked in with those parentheses. You can't touch this x. You can't touch minus 4 until you distribute the 3 there. So let's go ahead and do that. 3x, okay, and then this is a minus 4, but I'm multiplying by 3. Think of that like subtracting 12, or think of it as negative 12. Now, bring the plus 2x and minus 1 down below. What we really want to do is think of each of these terms as a separate entity. And frankly, my algebra teacher used to make me rewrite everything first as addition. 2x. Oh, squeeze it in. Okay, then use the commutative property. I'm going to flip-flop this 2x and the negative 12. Plus negative 12 plus negative 1. I get kind of sloppy with my parentheses. I don't always write them. You get 5x, and you get a negative 13. Now, you could write plus negative 13, or just write it as minus 13. They're the same thing. If you start thinking of just this minus sign, getting stuck with whatever follows it, and you always carry it with you, you can think of moving it around using the commutative property, because really it's like saying plus this negative value, and addition is commutative. Take a look at this one, because this one gets a little dicey, okay? You have the 5a and you have the plus 5, but I feel like I have to take a detour here. Will you put a circle around the minus sign and the 2? This negative sign sticks with the 2. I want you to think of it as like plus negative 2 times 3a plus 4. Do you see what they did here? Draw the arrow to distribute. It's not only negative 6a, It's also a -8, a -8. So when you go to combine things, do you see that they're just kind of boxing up, including that negative sign? And now they're going to rearrange the order by putting your A terms together and putting your constants together, combining those into a -1A, put a 1 there, I like that better, -3. Or you could say a -1A plus -3. It's all the same thing. Okay? In fact, they talk about this in question number 4. It says the property given is commutative property of addition, but this is really subtraction. Why is this not inconsistent? Or in other words, why is this okay? Because subtraction is adding the opposite. So what they are doing is they're kind of combining this together. They're sticking that negative sign with that value or with that expression, that term there, and that's considered legal. Okay? That's why. So flip it over to the last side here. Your job now is to practice on all of these. Okay? These first ones, you have to identify properties. See what they're doing to get from this side of the equal sign here and tell me, are they using the commutative property? Are they using the associative property? Are they using the distributive property? Which one? And if it's commutative, is it because of addition or is it because of multiplication? For the associative property, same thing. When you get down in here, you're trying to combine things together. So if I had to choose a nasty one here, oh, what should we choose? Should we choose something like, let's look at 11. Okay, and maybe what you want to do is think of rewriting it or boxing them up like I do. Take the sign right in front of it. That's 6 and a 2. They're plain old numbers, and those two are going to simplify to be 8. One term, 2 becomes 1. Then you have this -3h squared and a 6h squared. A -3h squared and a 6h squared. That'll give you one value of h squareds, whoopsies, and particularly +3. Boom, boom. Ignore that big old goob there, sorry. Okay? All right. Good luck. Give these a whirl. If you have some questions while you're working, stop me and ask me. All right? Good luck, and may the force be with you.